My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 611. In this lecture, we will try to understand CNN training optimization. So, now the big question here is, how does optimization part of convolutional neural network works? Remember, when we learned multi-layer perceptrons, we learned that we can apply backpropagation and all of the SGD variants, that we learned. So simple SGD, ADA, GRAD, ADAM, and all of these algorithms we can apply as long as all of our activations are differentiable. Look at the end of the day, we have X and we have Y, and we have some parameters. What are the parameters here? Weights are the parameters, isn't it? As long as we can compute the derivative of loss function with respect to weight, as long as I compute this derivative. Which derivative? Derivative of L with respect to W. Given this, we know we have X, we have Y. I have loss function L. What is my loss function? L of Y comma Y cap, isn't it? And I have loss function on top of it. Loss function. What is loss function? It's a function of Y comma Y cap, isn't it? Given X is input, W is a parameters, Y is output, and your X is input, Y is actual output. We know all this. Y cap is the output which we have got, isn't it? You need not bother about this particular equation. We discussed many times this one. This is core structure. This is the basics that we should not miss out. If you have any difficulty, please refer my previous lectures. Whenever you are designing a new architecture like convolutional neural networks, remember, CNN is very different architecture to multi-layer perceptrons. But the core of the back propagation is, if you have X, whatever, if you have X, whatever you do in between, I don't care. It has some parameters W. I get Y cap. I have loss function. As long as I can calculate the partial derivative of L with respect to W, or I can say partial derivative of L with respect to W, or WIs means weights. To be precise, W means what? Weights. Calculate the grad of L. What you have to calculate? Del of L. Calculate the grad of L with respect to W. As long as I can calculate my partial derivatives, I can apply backpropagation. The big question here is, in CNN, just see what is, as long as I can calculate my partial derivatives, I can always apply backpropagation, isn't it? In CNN, we have convolutional layer. Just observe, in CNN, just try to recall our previous lectures. In CNN, we have convolutional layer that we discussed, and we have max pooling layer, isn't it? We have to be sure that both these layers are differentiable, which means I am able to compute. What is the meaning of this? I am able to compute the derivative, isn't it? First, let's look at convolutional layer, isn't it? First, let's try to understand convolutional layer. What does convolutional layer here? It has the convolutional operator followed by an activation units like ReLU. We know that we already discussed about ReLU. We know that ReLU is differentiable, isn't it? What is ReLU? We know that ReLU is differentiable. What about convolution operator? What is the convolution? Convolution is basically element-wise multiplication followed by addition. This is exactly like your dot product. It is just like dot product, element-wise multiplication and addition, and your convolution. Of course, in convolution, you are using matrices. What you are using in convolution, you are using matrices, isn't it? In the case of this is element wise multiplication and addition. That is like your dot product, where we use generally dot product is in between vectors, the derivative and everything is same, isn't it? The derivative and everything is same. Look at this way. In my MLP, I may have weights from one layer to other layer. Weights is literally, what is this? Weight is literally, just see, I have layer here in my coordinate. What happens? Just observe this one carefully. The relationship from one, I have layer 1 here, I have layer 2. These two layers are connected by an edge. That edge has got some weights, isn't it? What about these coordinates? What happens? What happens in the case of coordinates? The relationship from one pixel to other pixels in convolutional neural networks, the relationship between one pixel to other pixel is dictated by kernel matrix, isn't it? I can represent the relationship between this and this. I can represent this just see, in the context of multi-layer perceptron, I can represent this relationship between layer 1 and layer 2. Just I can represent using simple, this relationship I can represent using simple dot product, isn't it? I can just make use of dot product. The relationship, but in the case of convolutional neural network, the relationship between input pixel and output pixel, is just a matrix multiplication, isn't it? It is element wise multiplication. And addition, isn't it? Which we know this element wise multiplication and addition, which we know this is differentiable, because your W transpose X, just try to recall about our multi-layer perceptrons. What is your Z equal to W transpose X in the case of multi-layer perceptron. Just try to recall our lectures on multi-layer perceptron. If you differentiate Z with respect to W, what will you get? You will get X. Just like dot product, your convolution is also just like dot product. Your convolution is also element wise multiplication and addition. So really it does not matter. It's a convolution is just like your element wise multiplication and addition. Really it does not matter. Everything works smoothly. The big question comes with max pooling, isn't it? We have two layers. One is convolution and other one is we already discussed about convolution operator, and the big question comes with, actually we discussed about convolution layer. In convolution layer, just if you observe carefully, in the case of convolutional neural networks, we have convolution layer. We discussed about convolutional operator. We discussed about activations like ReLU. Anyway, ReLU is differentiable. This convolution operator, which is element wise multiplication and addition, this is just like dot product in your multi-layer perceptron. That's what we were saying. Z equal to W transpose X, differentiation of Z, all these things. This is also differentiable. This one differentiable. This one differentiable. Now this one is completed. This convolutional layer, we don't have any issue with respect to differentiation. Now we will try to understand max pooling layer. The big question comes with max pooling, isn't it? So the convolutional layer, just try to recall what is convolutional layer. Convolutional layer is basically convolution followed by, just observe what is convolution layer. Convolutional layer is basically, just observe, just I am repeating things actually, just see. So convolutional layer is basically convolution, first convolution followed by ReLU, activation unit ReLU. Convolution is very similar to dot product, isn't it? Your convolution is very similar to dot product, except that it is done on matrices. Convolution we are doing on matrices, isn't it? So it is also differentiable. What happens with the max pooling? Now we will try to understand about max pooling. What are we doing in max pooling? Look at this way. Let's assume I have 4 by 4 matrix. Let's assume I have max pooling kernel. Max pooling with k equal to 2, s equal to, kernel size equal to, stride equal to 2. I got this output here with the help of max pooling. The first cell that I get here, isn't it? The first cell I get here came from the maximum value. These are the maximum. How will I get this first value? How will I get this value? I will get finding maximum of this, maximum of this, maximum. This is max pooling. From first 4 cells, I will collect maximum value and I will keep here. That's the procedure, isn't it? I got this particular output. I got this particular output here. The first cell, this is the first cell here, isn't it? The first cell I get here came from the maximum of these maximum of these 4 cells, isn't it? When I have to back propagate, just try to understand back propagation. When I have to back propagate, max function is not easy. Max function is very hard. Mathematically, it is complex one. You can't represent it and take derivative. So I need to somehow compute the derivative. Whatever the derivative I get here, I should back propagate, isn't it? I should back propagate to these 4 cells, isn't it? I should back propagate. I should back propagate to these 4 cells. I will calculate derivative here. I will calculate derivative here, and I will back propagate to these 4 cells, isn't it? That's the procedure in back propagation, isn't it? I should back propagate to the which 4 cells? I must back propagate to these 4 cells, this cell, this cell, this cell, isn't it? I need to somehow compute the derivative. Whatever derivative I get here, actually whatever derivative I get here, actually I have to back propagate here, isn't it? I have to back propagate the derivative to 4 cells. How will I do it? Let's assume I have values 1, 2, 3, 4. Just I am keeping these values for understanding sake. There are weights connecting to it because you have max pool here. Max pool layer is here. Let's assume these 4 values. Let me assume 1, 2, 3, 4. Whatever the derivative I get here, just see, that's what I am saying. Whatever the derivative I get here, I will back propagate, isn't it? I will calculate derivative and I will back propagate it. That's the important one, isn't it? Yes, I will pass it back. I will pass it only. Where will I pass it? I will pass it to only to maximum, isn't it? Where I will pass it to only, this point important. I will pass it back. I will pass it to only to the maximum unit. I don't pass it to the other units. Means I will calculate derivative here. I will pass only to this cell. I will not pass to this. I will not pass to this. I will not pass to this. I will pass to only. That's what I am saying. I will pass it back. I will pass it back to only to maximum unit. I don't pass it to other units. Means I will not pass here. I will not pass here. But I will pass to this particular cell. I don't pass it to the other units. There is a very nice Quora article explaining this. Just see this picture. I collected this from Quora. Here it is. Just try to understand this picture. Here it explains. These are all my values. Just let me say these are my values. I am performing max pooling here. Just what am I doing here? I am performing max pooling. This is how it works. I take the derivative of the output. Take the derivative of the output with respect to input, isn't it? For example, G is the output, X is the input. What I am doing? I am calculating dou G by dou X, the derivative of output with respect to input. It leads to be 1 because the derivative, just if you observe, just let me assume, for simplicity, I am assuming this value, this I am representing as x1. This I am representing as x2, x3, x4. For example, this is, let me assume 1, 2, 3, 4. Which one is maximum? 4. Therefore, as according to max pooling, which value will you keep here? 4, x4. Let me say x4. You have to calculate derivative of output with respect to input. Your output here is y. What is your output here? x4. Why? Because x4 has got highest value. That's output. As per max pooling, y equal to x4, as x4 is the highest value. Now I am calculating y with respect to x1. I am calculating partial derivative of y with respect to x1. I am calculating partial derivative of y with respect to x2, with respect to x3, with respect to x4. But you are getting only dou y by dou x4 equal to 1. Just I am keeping these values 1, 2, 3, 4 for understanding sake only, isn't it? Now what's happening? What's happening here? I take the derivative of the output with respect to the input. My derivative of the output is x4. I am taking the derivative of output with respect to input, means what? With respect to x1, x2, x3, x4. It leads to be 1, isn't it? I take the derivative of the output with respect to the input. It leads to be 1 because the derivative of it with respect to itself is 1. Dou y by dou x4 equal to 1. Why? Because you are derivating with respect to itself. That's why it's 1. The derivative of this value with respect to this value is always equal to 1. Y equal to x4. You are derivating y with respect, y means x4. You are derivating x4 with x4. That will be 1 because the exact value what I have to do here. This derivative I have to copy here. Isn't it? What is the derivative? Which one I have to back propagate here? I have to back propagate dou y by dou x4, isn't it? For the max value, you give the derivative 1, isn't it? For the non-max values, what is here? Just see here. Take the derivative of the input with respect to x, isn't it? What is the derivative? Dou g by dou xi equal to 1. Why? It's equal to 1 if xi equal to max. Here for max value derivative is 1. Just see here. What is the max value here? Its max value is 4. For whom the derivative is 1, isn't it? For max value derivative is 1. For non-max values means x1, x2, x3 derivative is 0, isn't it? Derivative of output with respect to input, isn't it? For max value you give derivative of 1, isn't it? For the non-max values you give derivative of 0, isn't it? Why? Because if dou z by dou xy, g is output, x is input, dou g by dou xi, which is equal to 1, if xi is max means the input output is same, therefore you will get 1, otherwise 0. Just like this case, I request all of you just try to understand this one. Here derivative of x4 with respect to x4 is 1. I will back propagate to this cell only. I will not back propagate this all other values. Here this value is 1. This value is 1. This all other values are 0. That's what I am emphasizing here. That's the important point actually. Isn't it? For my max value you give derivative of 1. For the non-max values you give derivative of 0 because non-max values do not define what the output here is, isn't it? In the case of non-max values, just see here non-max values is 1, 2, 3, isn't it? Non-max values do not define what's the output here. Here 4 is maximum value. It is defining output. When the derivative of y with respect to x equal 0 means, what does it mean? It means that your y is not related to x at all, because as x changes y does not change. As x changes, if y does not change, that means the derivative equal to 0. Your dou y by dou x equal 0 means what? Your y is not related to x. They are independent, isn't it? The derivative and these things is like, even what happens, just see here, I will even if you change little bit, if that means the derivative equals 0, and these things change slightly. These things change slightly in the context. If you change 1 as 1.1, 2 as 2.3, if you change slightly these values 1, 2, 3, it doesn't matter. Why? Because still 4 is maximum. I am keeping numbers only for understanding sake. Even if these things change, it doesn't matter, isn't it? It will not impact my max pooling, isn't it? Yes, even if these values change a little bit, it still this 4 is maximum. Why? Isn't it? It will not impact my max pooling. Why? Because this derivative again 1, I will back propagate here 1, all other values are 0. It will not impact my max pooling as they change slightly. Which one change slightly? Are the minimum values. If minimum value change slightly, it does not impact my max pooling, and hence the derivative equals 0. And this is the nice definition. This is definition for max pooling. There is an equivalent definition mean pooling or average pooling. In average pooling, you get the same average value. Average pooling is what is average pooling? You have to add the values. You have to add the values and divide with number of values. That's average, isn't it? What are you performing? You are performing simple in average pooling. What happened? You are performing simple addition and division. Isn't it? Then it's a very simple. But in the case of max pooling, what you do here is you only pass the derivative back. That's what I'm saying. You only pass the derivative back to the maximum value, and rest derivatives, rest of them you just make you just make equal to 0, isn't it? Here all our others are 0. Just observe, this one is 0, this one is 0, this one is 0, this one is maximum. That's what I'm repeating actually. Now we have everything now. We have 2 layers, isn't it? We have everything. We have 2 layers. We have convolutional layer, isn't it? You have max pooling layer. Both of them you learned how to differentiate, and since we know how to differentiate both of them, we can apply all of the mathematics that we learned in multi-layer perceptrons. I can use my back propagations, SGD, ADAGRAD, ADAM, dropouts, isn't it? All these things I can apply. Imagine if I have deep CNN concepts like dropouts are still useful because they are there to avoid overfitting. So I can use all the machinery like optimizers like back propagation, like dropout, optimization of optimizations of convolutional neural networks is exactly like multi-layer perceptrons, except the mathematics changes slightly, but fundamentally it is same thing. I request all of you, please go through these slides once or twice. Here what am I doing? If you observe carefully, just I am discussing about different convolution layer and max pooling layer, and both are differentiable. I related this convolutional layer with multi-layer perceptron. Just go through this lecture. If you have any difficulty, just please keep a comment. Thank you very much.